So in your textbook, the very first thing that we're introduced to is the tangent problem. And what I'd like to do is show that now. We're given a circle and a curve, and then we're asked to solve the tangent line for the slope of a curve for the function y equals x squared. Now, before we do that, let's see if we can get a better idea of what the tangent line looks like, where the tangent line would go, what does the tangent line do, and how do we create a tangent line to a curve. So as you can see to the left, this is the tangent line. It is simply a straight line. For a function such as a circle, Pythagoras, he said that for a squared plus b squared, that should equal the radius squared. This would be a function. This function or equation would create the circle. What it doesn't tell us is what the curve is, the slope of that circle. His equation only tells us about triangles within the circle that have right angles. Using a tangent line is going to allow us to find that slope. If I were to magnify this point and I brought it out here, remember it's magnified, I would simply have a portion of the curve, and this would be our point. So let me redraw that. We're magnifying this point, and it would just simply be a small curve. And the tangent line would pass between two points so close that you couldn't tell that there were 2 points there. By doing that on a scale that is so close to each point being equal in value, that we are able to find the slope of that curve at any given point. So we're going to get into a lot more detail about the tangent. We're going to be working on what's called a secant. And a secant is the same thing, but on a scale of points, such as in this next graph, such as 2 points further apart on the curve. And what calculus is basically going to show us is that as my point for a secant line gets closer and closer to my point P, it becomes a tangent line. That is a very basic definition. I've also given you a little bit better definition here that states a tangent line is used to find the slope of a curve created from a function like y equals x squared, and that is figure 1. Y equals x squared is a parabola. And often this course will refer to that point as P, as you can see here. So a tangent line is a line, and it barely touches. So like I said, it barely touches as it passes along that curve of the circle. It barely touches that point. And it touches in such a way that we can find the slope of the curve at that tiny, tiny point. So in the next video, I'm going to walk through the example one that's also in your textbook. And hopefully this will give you a little bit better understanding of how to find the tangent and what the tangent is. Later on, we'll have a better understanding of why the tangent line is so critical. Thanks for watching.